So how are you, students? Welcome to this session where we shall be dealing with rectification. Rectification simply means rectification. Rectification is a process of converting an AC voltage into a pulsating DC voltage. So that is the definition of rectification. Remember, we have said rectification is a process of converting an AC voltage into a pulsating DC voltage. So we need now to go down into types of rectifier. Then we need to define also something that is called a rectifier. So a rectifier is a circuit. Rectification is a process. So the circuit that is going to be used to carry out the process of rectification is called a rectifier. So what is a rectifier? So a rectifier simply is a circuit. A rectifier is a circuit that is used to convert, is a circuit that is used to convert AC voltages into pulsating DC voltages. So having defined a rectifier as a circuit that is used to convert an AC voltages into pulsating DC voltages, then we now want to analyze the various types of rectifiers that we have. Then we would also say broadly rectifiers are of two types. Rectifiers are of two types. Number one, we can talk about half wave. We can talk about half wave rectifier. We can talk about half wave rectifier circuit. Number two, we can talk about full wave. We can talk about full wave rectifier. We can talk about full wave rectifier. So we have said broadly a rectifier circuit, and remember we have said a rectifier is a circuit that converts an AC voltages into a DC voltages. I think you remember in our first class we discussed the block diagram of a regulated power supply. We said the first stage was a transformer. The function of the transformer was to bring down the voltage levels to the required level, that is. Then the second stage was rectification or a rectifier. We have said a rectifier is a circuit that now converts the AC into a DC voltage. So we are saying broadly the rectifier, that circuit can be categorized into two main groups. And the first group is we have the half wave rectifier, and the number two we have a full wave rectifier circuit. So what is the difference between the two? Half wave, from the word half, it means we are taking half of the signal. Remember, a full signal has got a crest, and it has got at the lower side of it, or the trough, because we know an AC signal has got two parts. We normally say this is a crest and this is a trough. So this is half of the wave. The full wave now, the full wave means we are taking the two cycles. This is the positive cycle. We can say this is the positive cycle, and we can say this is the negative cycle. So a full wave, now this is a full wave. So a full wave comprises of the two parts of this half cycles. The first half cycle is positive, the second half cycle is negative. So for a full wave, it must have the positive and the negative. So when we talk about half wave rectification, it means strictly we are only taking half of the wave, probably the positive cycle and not the negative cycles. So that is what it means by half wave rectification, meaning we are only going to rectify half of this wave, not the whole wave. Number two, we discuss about full wave rectifier. A full wave rectifier circuit, it means it will take both cycles. It will take the positive cycle, it will take the negative cycle, and that is why it is called full wave rectifier. So I want us now to discuss into details half wave rectification. I want to look into details half wave rectifier circuit and how it happens. Remember, there is a note that we need to take, an NB, that a diode is used. A diode is used for rectification process, is used in rectification because it offers high resistance when reverse biased, and low resistance when forward biased. So we have said a diode is a device, an electronic device, and we have said it is commonly used in rectification because it offers high resistance when reverse biased and low resistance when reverse biased. Remember, when we were dealing with the PN junction, we said an example of a PN junction is a diode. Remember, the symbol of a diode takes the shape of a triangle like this, where we said this is the anode and this is the cathode. Probably you can say this is the P side and this is the N side. So that is the symbol of a diode. This is the symbol of a diode. So this diode is used in rectification because if you connect this part, so when this side is positive, assuming, remember an AC circuit keeps on changing. When this side is positive, this one is negative, meaning current flows in this direction. Remember, we said a diode is a very good example. We can use the water analogy to explain what a diode is. A diode can be likened to a valve. A diode can be likened to a valve. And remember, if you deal with a water valve, you can illustrate it like this. A water valve can take something like this. We have another block there, and let us say we have a spring here. So what happens is, when water is passing in this direction, the force of the water can open this valve. But if water comes from this side, the water will be pushing this link. It will just be lying on this one and it will not be able to open. So meaning if water flows from this direction, it can be able to push this lid to open it, because it is hinged at this particular point. It is hanging at this particular point. But if water comes from the other side, it will not be able to open, because once it pushes and it lies on this point, it will never open. So we are saying a diode can be likened to the valve. The valve only opens in one direction and it never opens in the other direction. So we are saying the diode will only allow current to flow in one direction. And that is why it is actually used in rectification. It is used in rectification. So we can now deal with the first type of rectifier, which is a half-wave rectifier. A half-wave rectifier circuit. So number one, we can deal with half-wave rectifier. In half-wave rectifier, we said the first stage is you must draw from the input point, it goes to the transformer. And basically we said the function of the transformer is to step down the voltages. After you have moved from the transformer, you now go to the rectifier circuit. Remember, in half-wave, one diode is used. That is the most important point that you need to understand. So we're going to connect the diode at this point. And then we put our load here. So for purposes of explanation, let us say this is the load and this is the diode. So for purposes of explanation, you need to, this is our AC mains, which is coming. This is the transformer. And whenever you're explaining half-wave rectification, you need to talk about what happens during the positive cycle. Positive cycle. And later on you will talk about the negative cycle. So let us say, if this is point A, let us say this is our point A, and this is our point B. That is our point. This is our point A, this is our point B. Let us say this is our point C, and this is our point D. So what happens during the positive cycle, we can say, during the positive cycle, point A is positive while B is negative. So the first point you need to analyze is, you need to tell us the polarities, because we are having an AC. Initially this point becomes positive, this is negative. At another instance this will become negative, this becomes positive. So we are saying during the positive cycle, we are letting point A to be positive, this one to be negative. So that is why the statement reads, during the positive cycle, point A is positive while point B is negative. So after you have identified the polarities, then you can now tell us the status of the diode. The next step is to give the status of the diode. So what happens, because these are positive and these are negative, then it means this diode is forward biased, because we said forward biasing means you take the positive terminal of the battery, you connect it to the P type. Remember, this is P and this is N. Because the positive, during the positive cycle, the positive is connected to P, the negative is connected to N. then the diode will be forward biased. So we will say the diode is forward biased. The diode is forward biased. The diode is forward biased, hence it conducts current in the direction given by. So we are saying because this diode is forward biased, it will now conduct current. Current will be able to flow in this direction. So the current flows in that direction, meaning it begins from A. Just give it here. It begins from A, it goes to the diode. And then from the diode it goes to point C. It goes through the load. It goes through point D. Then it goes back to point B. So that is the direction of flow of current during the positive cycle. We can look at what happens during the negative cycle. Negative cycle. During the negative cycle, you can just have it here. Negative cycle. So we are now interchanging the polarities. During the negative cycle, this one now becomes negative, this becomes positive. We are reversing the polarities. So during the negative cycle, point A is negative, while point B is positive. After you have given us the polarities during that cycle, you now tell us the status, the current status of the diode. The diode is reverse biased. The diode is reverse biased. Why are we saying it is reverse biased? Because the negative is connected to P. The positive, because remember, in this particular case, B is positive. So the positive is connected to the negative is connected to P. That means the diode is reverse biased, hence it does not conduct current. Does not conduct current. So we are only saying that during the positive cycle, current flows, meaning the load only receives current during the positive cycle. But during the negative cycle, there is no current flowing because the diode does not allow current in the reverse direction, meaning the load strictly receives current during the positive cycle. The most important point here to note is that the load receives current during the positive cycle. That is why it's called half wave, because the load is only receiving current during the half cycle, 1/2 cycle. And that can be the conclusion. The load receives current only during the positive cycle, hence the name half wave. So we are only receiving half of the wave because the other negative half is cut off. So we can just draw the diagram and finish up on this particular area. we can draw the voltage and the current waveforms. We have said at the input, at this particular input, at the input point, we having can draw it here. We have said at the input you will be having this cycle coming like that, like this, like that, like that. So this is the input, and remember this is our voltage. So during the input point, if you put your CRO at this particular point, this is the kind of waveform that we expect to see. But after rectification, this is what you will be able to see. It is good for you to extrapolate these lines downwards so that the diagram matches what is on the other side. So we are saying you will be able to find this. So that tells you that during the positive cycle, you will be able to receive current, but during the negative cycle, this one has been cut off. This has been cut off. You will find in most books, they don't draw this. That one is not drawn simply because the current just comes at this point. Then during the negative cycle, the load receives 0. But at the eve of the positive cycle, you will get the wave is coming up. And this one is 0. So meaning the load only receives current during the positive cycle. So that is basically what happens